Yo, what's up, guys? What's up? Hello, Evo. Hello, network guy. Yo, Chris. It's funny because Chris wasn't first this time. Chris is always usually first. Hi, Paul. Yes, back at it again, my friend. Another day, another dollar. Working the grind. So we're going to try and get rid of some well, we're going to try and get rid of some amplifiers which have been giving me a little bit of headaches over the last couple of days. Nothing too crazy. Got an Evo SSL, the SSL Evo 5000. This is the first one that we're going to be having a look at today. Now, this amplifier we were looking at before, and we couldn't get the thing to switch. The Class D switching wasn't really working properly. We'd replaced the original A42 and A56 transistor drivers with MJE parts, which I'm not sure it was too happy about. So yeah, we're going to be replacing those with the original parts. We ordered the original parts, A92s, and we've got A92s. So the only ones I'm missing now are the A56s. You guys should be able to hear me quite well. If I turn it, you guys should be able to hear me well enough like that. Here we go. I think these are the. Here we go. These are the 56s. Okay, cool. Quick question. I got a new JBL 1401. It doesn't sound to make at much. It seems to make as much power as your. What the fuck? Yeah, you've got issues there you need to look into. 14001 makes 1950 watts at 2 ohms. I bench tested that. It's very, very good. Music shouldn't be very loud. Music should be really quiet. I just tested it. I just did a test stream to see how loud the music was. Can you hear me now? Yeah? Can you hear me now? Okay, good. Good. Alright. So, SSL Evo 5000D. We're fitting it with all new driver transistors. So what we need to do now is go to our. I made a list on my computer screen here of all of which drivers went where, so I could remember, because there's a lot of drivers here and there's a lot of different types. There's 3 different types of drivers. Oh, my throat is absolutely killing me today. It's quite a bit of effort to talk. Hello to DJ H, how's it going? Okay, so let's have a look then. So, 41A, so location 41A on the board is, here, over here, let's get the other view. So these are the drivers that I've got to replace in here, okay. A is an A42, so 41A is up here, that is an A42. So let's put that in there. That's one. The next one along, let's have a look, what's the next one on my list, is a 40A. So 40A is the next one down, and that is also an A42. So let's drop an A42 in there. The 46A, which is the next one along, is a 92. So let's drop a 92 in. Is the music must be really quiet now. You guys probably can't even hear the music now. I did test it and you could hear my voice over the music earlier. I thought you could anyway. 46, so 45A is also okay. That's a 56 rare. There we go, 56. And a 56. Yep. So 2 56s, and then the next one is a 36A, which is a 42. That's one of these ones. And 35A is a 42. And the next one along is the 49. 49 is an A56. That's one of these. I'm not convinced these 56s are genuine. The legs seem very, very thin. And I had to get these 56s from eBay because there was none in stock anywhere in the UK. They're being discontinued. So I'm not too convinced about these ones, but we shall see. And then 37A is a C1027, which I shall replace momentarily with something that I've got already in the drawers. Okay, let's go along to this second row. So we've got 47. Let's have a look. So 44A, which is this one, is a 92. Evening Prince. And 43 is a 92. 42 is probably going to be a 92 as well. Yep. Okay. 38A. 38A. 38A is a 92. And 39A is a 92. Another one of these, another one of these. Okay, so the only ones we've got left now are this one here, which is the 47A and the 37A. Now this is meant to be a 1027 and a 1023. Which I should have in my drawer somewhere. Now this is the SSL, this one. Okay, so C1027, that's this one here. I've got one of those, perfect. And I need an A1023. There's an A1023. I'm going to get a couple of these out. I want to make sure that I've got one that works properly. See, I've got another C1027. A1023. Cool, that should be enough. So the last remaining 2 transistors that we need to put in the board. See, they're all wobbling around a bit there. Let's get our transistor tester and just make sure that they all read roughly the same, so we can find if any of them are bad. So let's start with the A1023s. So we're going to look for a common reading here. So we've got 160 of the HFE, IC of 1.5. Okay, so that's 160. E1023. Let's try a second one, see if it's roughly about the same. Yeah, 166, that's roughly about the same. That's also pretty good. We'll try one more, which is the best of 3. 173. Okay. I've got a 4th one here. $160. Okay, we're going to go with one of the 160s. So this was the A1023. So that location was 47A on the board, which is up here. Yeah, man, get in the hole. Might need to suck the solder from that hole a little bit more actually. Oh no, there we go, it goes in. So the last one is the C1027. So let's check these for continuity. Oh, 163. $97. Okay, I think that one's slightly wrong. So we're gonna forget this one. And we're gonna go with this one. Yeah, many amplifiers share this circuit design. It's not too dissimilar from the likes of amplifiers made by Soundstream, in fact. Oh, my throat feels horrible today. Yeah. Drive check is horrible, yeah. Ugh. The sinuses all feel horrific. Okie dokie. There we go. So, all our drive transistors are now in place. So what we need to do is get these soldered in without them all falling out. So I'm just going to push them all down. I'm just going to go and bend the legs a little bit on the bottom, on the back, so they don't fall out. I've been drinking absolutely loads today. So it shouldn't be dehydration. It should be quite hydrated today. What's up, Robert? Yes, man, back at the daily grind. Daily grind. Gotta make my peas. Hopefully that's bent enough for them so that it'll stay in the board and don't fall out. Yeah, cool. Although it is very hot in this workshop, so it could be too much heat. I have the heaters turned up pretty high in here because I do not like the cold. I'm not a cold person. Well, I'm a cold person, so I don't like the cold. So the DC9K from last night works beautifully. I've been doing some endurance testing on it today. It works wonderful. And I fixed the LED as well. I've now got a bright blue LED inside. Looks good. Okay, let's get rid of all those, snap off all those legs. Ugh. Not feeling too good today. Good evening, Carlos. Okay. Okay, we've so we fitted all new drivers in there. So the drivers not the amplifier not liking my replacement drivers was the only thing that I could really think that could be wrong with this amplifier going forward. Let's pause this music out. So yeah, so this amplifier came in, and yeah, it had some blown driver transistors around here. So yeah, I replaced the blown driver transistors with MJE 340 and 350, but that didn't seem to help. It didn't seem to help. We still had no Class D switching. We did get a square wave on the op amp, on the IC over here, but it wasn't going through the drive circuit as intended. So now that we've basically block refreshed the whole drive circuit. So if this doesn't work, then I am out of ideas. I'm going to take myself a sacrificial 640N just to drop it in the board and see what happens to start with. I've got 2 sacrificial 640N FETs, just in case this doesn't work and it kills the FETs. I don't want it to kill any of the new ones I bought. So I'm just going to drop those in place real quick. Yeah. It looks like a Class AB. Well, this. In this one, it's a regulated power supply. Power supply drive IC it's using is the KA3525A, and it is a regulated power supply to some extent. I haven't actually checked it. I mean, that IC, that chip does have the means of driving a, having a regulated power supply. Whether SSL have incorporated that into the circuit, can't remember, but it should do. It should have a regulated power supply. Hi Nid Frost, how's it going? So this is the point where this either works and we celebrate and put it back together, or it doesn't work and we give up, because I've changed absolutely everything that I can think of on this board to get it running. So this amplifier we've actually been working on over quite a few different live streams. So this is kind of like the last final straw for me with this. If it doesn't work now, then it's not worth my time. It's not a very good amplifier anyway. So it's not worth my time troubleshooting it much further and wasting any more of my time. Yeah, this is the EVO5k. Just a quick pre-check to make sure there's no shorts on the output before we turn it on, because that won't end very well if there is. Cool, looking good. Okay, power time. Hi Vladimir. Yo, how's it going, Nicholas? Nicholas, this is the last final straw for me with the SSL Evo. We block replaced all of those, all the driver transistors. Remember you were helping with this one. So this is literally the last thing I thought that we could do is just block replace every single one of these. And so we've already replaced the IC. So replace every single one of these with original parts, with the original ones that it's designed for. If it doesn't work now, then meh, kind of give up. Rare. So still no drive. Although it's not going into protect anymore, I don't think. Is it? I have to give it a couple of seconds. So before it was bouncing backwards and forwards between protect and operation. We still have 2 volts worth of DC on the speaker terminal. There's a little bit of switching or something. There's something trying to switch. Oh man, I don't know. Look at this baby little. Look at this baby wave we've got. What frequency even is that? That's the power supply frequency again. So we've got. It's still climbing up. We've got climbing DC on the speaker terminal. So on the positive speaker terminal, we've got this DC that slowly climbs up. It's up at 4 volts now. So it's doing the same bullshit thing it's been doing the whole flipping time. Now we're at 5 volts. Oh well, thank you very much, Thomas. Thank you for your 50 Norwegian kroners. Massively appreciated. Okay, so this thing is still oscillating backwards and forwards in and out of protection, but it's just doing it much slower. Now that I've ordered these new parts, it's doing it much slower. Is something open, Sam? What do you mean is something open? Oh, no, I don't think so. Nah, the output FETs in this never get hot. I've got 2 640Ns. All it's doing is it's pulsing the look, you can see here. Check the scope out. So the output. This is what the positive speaker terminal is doing, and it was doing this before we replaced all of our drive circuits. So our drive circuit was probably fine. So this is the positive speaker terminal. DC slowly rises, gets to about 12 volts, and then goes back down. When it goes back down, the amplifier goes into protect because it notices there's DC on the outputs. If I probe pin 1 of the op amp, which is responsible for this area, yeah, it sits at -7 volts. We then get this wave here. So whilst it's in protection, we get this wave. When it goes into operation, it sits down at -7 volts. Yeah, I literally have no fucking clue. I don't know what to change next. I've pretty much looked at everything that I can think of in this amplifier, so okay. Time to give up on that one. It's not worth our time. Although I think I will take back all these precious drivers. They get pretty warm. That's the thing, they heat up quite a lot. Throat feels horrible. So what I'm going to do is I'm going to leave this one. This one's a no fix. We spent far too many hours on it already. It's not worth our time. So I'm going to remove my 2 640Ns. I'll leave all these new parts in the board for the time being. They're not hot. They're like just probably about 25 degrees. They're just lukewarm. They're not hot. They're just, you know, they're just a little bit warmer than like cold things. I did find the 15 volt supply. I'm sure I did. Yeah, it was around this section in the middle. It was around here, wasn't it? This was the 15-volt supply. And actually also the other 15-volt supply is generated over here. We've got a 7,915 and a 7,815. So plus and minus 15 volts also generated over there. Yep, check the output coils. Output coils all both have equal inductance and they're not shorted. The output coils having an issue wouldn't cause there to be DC on the output like that. DC on the output like that is a sign of a drive issue. So I don't know. Can't be bothered with this. So let's put that one back away then. Let's put that one back away, and that can go back to Gordon as it's fucked, and I have no fucking idea. I don't have a circuit diagram for this. No, I have patches of circuit diagram, Nicholas. I have like small bits of schematic for generic drive circuits that simulate this. If we go to Perry's guide, I can maybe show you. Here we go. Yuck, I feel gross today. Okay, so for Nicholas and anyone else that's interested, so there's a general, a sort of schematic here for a similar amplifier, and there's also a basic schematic for the drive circuit, I think. Yeah, I think this is the basic schematic for the drive circuit. So we can zoom in on. Well, here we go. We can look at this. This is the drive circuit, the schematic for the basic drive circuit. This contains the op amp and all the driver transistors. So if Nicholas was interested in that. Alright, so I'm gonna leave the schematic up on the screen there while I put this amp away and grab something else. So this is the Crescendo 2-channel Class D full range amplifier that we fixed. We found a shorted diode on the back and other things. So yeah, I think we pretty much fixed this. The only thing I had left to do with this one, which is why this video is called tying up loose ends, I needed to fit the original FETs in place. So it seems to work well with the 640s. So obviously I ordered some of the originals. I have to remember which FETs this amp used. Okay, it might be these ones. These are 33N15. I think it was those. Yeah, I think it was 33N15 from what I remember. Ugh. What's up to the third era? How's it going, pal? So I'm just leaving that driver board schematic up for anyone that's interested in seeing if they can spot anything that might be causing the issues I'm having with the SSL. But to be fair, I'm kind of done with it now. Kind of can't be bothered with it anymore. Nicholas says, did you check the resistors between the push-pull stages? I think so. I think that was one of the things I did on the very first live stream that I looked at it. I can't remember, it was quite a while ago now. I could check them again. Once I put this Crescendo back together, we'll check it again. that's enough of the schematic. Okay. So 33 and 15. These do sit quite high on the board up here. Bad distortion at low volumes could be a whole host of things. There's no chance of me diagnosing that over the internet, sorry. Could be so many things. If you're unsure of something, take it apart and have a look. Well, have a listen whilst it's all out of the system. See if you can work out where the distortion noise is coming from. I'm always losing my stupid tweezers off this desk. There they are. Where did you get schematics? The internet. Alright, so this amplifier seems to work just fine with 640Ns in the board, which are not the original FETs for this, so I feel like crap. So now let's just fire it up with the original FETs in, and that should be everything done with this. Provided it does not explode, then we should be done with this. Okay, so let's try. There we go, nice switching, nice high voltage. Nice. How hot did they get though? Because they got pretty hot last time. They did run quite warm last time, so they're already heating up quite a bit. But Nicholas did tell me that these do just run warm, so... Because it's a very, very fast switching frequency. So the switch frequency on this is 375 kilohertz. So they're already sitting at 50 degrees. 48 degrees, and the thing is drawing 2.2 amps. 55 degrees now, so yeah, I think they run a little bit warm. I think that's fine. They kind of actually run a bit too hot to touch. I don't know if that's intentional. Wow, they do run really quite hot, but I can't see anything else wrong with it. The drive waves all look great, so inductors are staying cool. So yeah, it's probably fine. I guess the only way to know is to run some power to it. So we can put it back in the case and we can drop a bench test, I guess. See what the bench is, 27. I'm going to flip her over and just see if anything gets hot on the circuit board side. Oh, wait a minute. That was doing the super slow switching again. Oh, that was the power supply, that's why. Ha! I probed the wrong FET. There we go. Let's check if anything on the circuit board side gets kind of hot or not. Okay, I've got something over here that's getting damn crazy hot actually. Okay, so there's a couple of parts over here that run pretty hot. Is that a capacitor that's running hot? Something's running really quite hot over here. It's a really small part. I might need to look into that. The thermal imaging camera is not quite high enough resolution to see what part that is that's getting really hot over here. So I'm going to spray some alcohol, just here, and we're going to see what evaporates. Okay, so it's evaporating from these capacitors very quickly. And possibly this 102 resistor, which will be a 1000 ohm resistor. So we've got a couple of capacitors here which seem to run very hot, and a 1000 ohm resistor. So let's see what's actually on these parts. So we have 40 volts rail and 12 volts. So that's why that's getting hot, because that's dropping 40 volts to 12 volts. These capacitors have 40 volts on it one side and nothing on the other. I wouldn't have thought that would get hot. It has 12 volts on one side and nothing on the other. These xenodiodes, 12 volts on one side, nothing on the other. These are, and then that's the 6 volts on one side and nothing on the other. Something very hot over here, but I think that could just be FETs. I'm going to remove this 1000 ohm resistor and see whether it's gone out of tolerance. It appears to be getting possibly a little bit too hot for my liking. And it falls down to ground incredibly quickly. It falls down incredibly quickly. So I'm just going to wait for the voltage to discharge. See you later, Prince. Thank you. Okay, so that does read 1000 ohm, so that's doesn't appear to have an issue. These capacitors should read nothing one way and then charge the other direction, which they do. So perhaps something in this area just does run a little hot. I'm not sure if this Zelda is leaking in one direction actually. Hi Luca, how's it going, buddy? Thank you. It's not too nice to be working again because I feel like shit today. It doesn't seem to read anything actually. Hola a todos, hola Miguel, hola, buenas noches. Aquí es a las 9:30 por la tarde, por la noche. That does read as a diode on the meter. Nah, let's just put it back together and bench test it, see what happens. As Nicholas said, perhaps these just do run a little warm. I was just a bit concerned about how hot some of the stuff was getting in this area. That's all. Miguel, ¿cómo se dice to repair en español? To repair. I repair, he, she repairs. Reparar. I thought it was something similar to that. So, I repair is reparo, reparé, reparamos. Voy a reparar muchas cosas esta noche. Hopefully. Okay, so I'm going to put this back in its heatsink because I'm not convinced about the amount of heat that the FETs are kicking out at idle and how much current the thing draws at idle. I'm not too convinced, but I'm going to put it back in the case and I'm going to just run some power through it, run some audio through it, and see whether the FETs die or not. Yeah. So where's the clips for this amp? Did he include them? Not too sure. did the technician. So yeah, Volvo. We tried fixing the SSL Evo again, to no avail. That didn't happen. So we've given up on the Evo. We've spent far too many hours trying to repair that hunk of junk. So let's leave that. Not worth our time now. I will check one more thing though. Nicholas said to check the resistors again. I think I did check them, but I want to make sure that I did. Now we just moved on to this Crescendo that we pretty much got up and running the other night, but I needed to order the original FETs for it. So I ordered the 31. What was it? 31N15. Yeah, I think that was right. 31N15. Oh, no, sorry, 33N15s. So I've just loaded those in. They run kind of hot, but that might just be how this amp's been designed. So what I was going to do is I was going to put it back in its heatsink and clamp the FETs to the heatsink and run some power through it, but I'm not sure where the clamps are for it because I don't know if the technician who sent this to me included the clamps or not. Okay, I found something. I found a something in the box. I found a something. This is a full-time job for me. Yeah. So this is just a packet of bubble wrap. What? Why would you send me a packet of bubble wrap? Okay, fine, no worries. Free bag for amplifier parts. And what do we have here? We have a we have some shit here, but I think this is not the right. These are far too big. This is not for this. This is for something else. What's this for? No, this is for something else. I could temporarily use these clamps, I think, maybe, just for now, just for a quick test. Yeah, let's temporarily use these clamps just for now, for a quick test. Let's see. Actually, no, fuck it, I can't be bothered. I cannot be bothered. I've got to take them off again. Nah, fuck that. Screw that. Let's move on to something else. Let's put these in a nice bag, nice and safe, so we don't lose all those parts. What's this? OB. I do have some spare clips in this bag though. Volvo, yeah, the DC9K, yeah, we got that working. That works beautifully. I've been running some tests on that today. Works great. So I have no idea what those parts were for because they don't match up with any amplifiers that he sent to me, so that doesn't make much sense. But there we go. So it was an out of tolerance resistor. What else? What else was it on that amplifier that we fixed? Out of tolerance resistor. Yeah, we also obviously we cleaned it all up from the solder flux, and I installed all the rest of the FETs, which I think made it happier. Cool. All right. Let's call that fixed. And I'll do tests on it once I work out where the hell they sent the clips to. Okay, Lanzar 7K, and no, this is not the full board. This is not the full Lanzar 7K board, of course. This is just the output section. So, if you're thinking it looks pretty small, then you're right. It's pretty small. So, for this amplifier, we needed a new driver IC, which I think I have here. IR2113, here we go. IR2113. So we have a replacement IR2113. Now this amplifier is very useful because it already has headers for us to slip the part into without having to do any soldering. Would you be interested in a pallet load of amplifiers over 600 amps? 40% massive audio. I have no idea where I'd put them, but possibly be interested depending on what they are and what the price is. Okay, so it's our new driver IC. There we go. So now I need to power this board up, and I need to see if the drive waves look good or not. We already fixed the power supply on this board. So on this amplifier, we've already fixed the power supply, which is on a separate board, which I'll get in a moment. And we also ran a trace that we repaired. We repaired a trace because that was blown on the board over here, so that's good. So and also we need to fit the inductors. So the inductors also got damaged, but we can fit those after we check the drive waves. So I'll check the drive waves first and then fit the inductors. Back pain was too much to consider to carry on with the repair. Also, you have 600 amplifiers that are blown. I'm not sure about that. That might be a bit too much of a task to take on just now. Yeah, I'm not sure if I could be doing that. I'm not sure if I could take on 600 amplifiers that need repair. I might buy like a selection, but I don't think I could. I don't think I have the time or the resources to take on that kind of workload, unfortunately. I'd love to. I'd actually love to do that. I'd love to take that on. I think I have too much other shit to do. They are all inventory amplifiers the customers declined to repair. Yeah, but if someone's going to buy 600 blown amplifiers, then they could, is like, to, you know, they're going to want to be repaired at some point so you can sell them, perhaps, which would be cool. But I'd love to do that. I'd love to do that. I don't think I have the space just now, and I also have a lot of too much other shit. 600 is like a crazy amount of amplifiers. If it was like 50, then I might be like, okay, I could work through those over the course of a year, perhaps, on top of my everything else I have to do. But 600, it's like a bit daunting, you know. Okay, so power supply board for this Lanza is plugged in. You see it looks pretty big now. It's not massive, it's like an okay-ish size. It's not huge for a 7K, it's like kind of smallish for a 7K to be honest, but yeah. So, yeah, I'm going to get her powered up now, and then we are going to have a look and have a look at the drive waves on the output section, make sure that they are looking good, because we've fitted a new driver IC over here, so we should have good looking drive waves. If everything goes to plan, we should have good looking drive waves. Cool. Okay, we have good power supply switch wave. We have humongous. We have 93 volts on the on here. So you can see we have negative 96 volts and positive 98 volts. Okay, so now we need to see what's going on. Do we have drive waves where there should be drive waves? So we don't have any drive waves just yet, but that's possibly because I need to. Perhaps it's drawing quite a bit of current actually. It's drawing over 5 amps. Holy Jackamole. Wowzers. Okay, so we have most certainly, I can't touch that with my finger because that is too hot. We appear to have a dead 7812. So this 7812 was reaching 150 degrees, so that's got to go, and that's why my amplifier was drawing 5 amps. Yep. Can you see that? You can't see. You can't even see this now. But yeah, absolutely red scorching hot. KA712. So that's not ideal. So there's some issue there. It's either a dead 7812 or it's something is shorted on the pads or something, because that got hot very quickly. Yeah, Farouk, if you have my email address, buddy, send me a list. Maybe we'll try and get maybe we'll try and get a few people jumping on that, and we can do like a group order. Okay. So let's remove that 7812, because that is most certainly dead. Okay, so yeah, we have a short circuit across this 7812. It might be a good idea to remove all of them and replace all, I don't know, replace all of them maybe? Can check the readings on all of them. Okay, so yeah, the 7812 most certainly died, or was dead already. So, do we have a short circuit on the do we have a short circuit on the pads? That's the question. Okay, so there's no short circuit on the pads. So I think the 7812 just died, and that's possibly what killed the amplifier. I'm just going to check the continuity on all the others. See what we've got. So we should have about 536 on all of these. 568. 40. Okay, so let's fit a new 7812. I think I have some spares of those in my rectifiers drawer. Let's have a look. KA7812, there's one here. So this one needs to go in the bin. KA7812 here. A key. Okay, that's a new 7812 fitted. Let's just make sure that the continuity values are roughly the same with the other ones. Here's a slightly different model. It is a slightly different 7812, so it might be slightly different. Let's have a look. 43 there, that's about right. That'll be fine. It's hot, so. Alright, cool. So let's plug her in again, and let's monitor the temperature from the word go this time. From the second it turns on, I'm going to be monitoring the temperature. Good evening, Belgium is online. Awesome. Okay. Let's try again. Temperature monitoring. See if that thing heats up. Wow, okay, so it still gets... Ah, wow, so something kills it. So it just reached 100 degrees in like literally no time at all. So something is killing that 7812. I wonder if it died straight away. I didn't let it stay on for too long that time. But it still got to 100 degrees in like no time at all, so something's killing it. Alright, that time... I think it did die. Ah, crap. Well, what's killing that then? What's killing that? So there must be something else on the board that's short somewhere that's killing it. Killing me softly. What I might do is I might power the board up with all of the 7/812s removed, or just with this one removed, and see what's going on the board. Remove the drive ICs. Ah, okay. Good plan, sir. Alright, let's do that. Let's remove the ICs. I forget that with this board it has the ICs in headers, so I can quite easily remove these without any dramas and soldering. So yeah, very quickly, easy, just remove these. Which is probably a good plan, just in case they die or something kills them, perhaps. Okay. Ski up. So did that just kill it? Or did it survive? Was I quick enough? The refresh rate on the thermal imager is so slow. It jumped up from like 30 degrees to 100 in like 2 frames. Ah, man. So yeah, it killed our replacement crap. I think I've only got one more of these, so I need to be careful here. I have to order some more, and we have to put this one to one side for the evening. So, okay. What's going on here then? Why is it killing these? Let's just check if there's not a short to ground on one of these. Doesn't appear to be a short to ground. Okay. So I might power the board up with that one removed. So there's no driver ICs on the board that require them. What's it actually connected to, though? If something is killing it, something must be drawing excessive current from it, perhaps. So that's going to be the voltage input. So let's see, what does this output feed? See, the voltage of this pad might be the same, Just the current draw from it is different. That's the thing. So alright, let's power up then and compare it to the others. To compare the voltage on it to the others. Yeah, nice. So now the amp's only drawing 2.4 amps. The thing's only drawing 2.4 amps now, which is about right. That's about the pull down resistors, so okay. Cool, so I'm safe to leave this powered up whilst we probe around for a bit. Okay, so let's see what we got going on these 7812s then. So okay, pin number 1, we have our negative 78. Pin number 2, we have our negative rail. So the 78 is the 12 volt, is the regulated 12 volt, I believe. And on the third leg we have 83. Oh, hang on a minute, no, 95, 85. So sorry, the third leg is the output. That's 83 volts. Okay. So the third leg is the output. So we shouldn't have any output on this pad that we just removed. Rare. Okay. So that could possibly be the issue. So on the pads of the one that we just removed, on pin 1 we have 77 volts, which I think is correct. Yep. Pin 2 we have our negative rail, which is 94 volts, which is correct. On pin 3 we also have negative 95 volts. So that could be what's killing it, because yeah, could be what's killing it. Pin 1 we should have 70. Wait, what? The ones on the other side are different. They're doing something different. They're taking 18 volts down to 12, not the main rail. Okay, cool. I'm seeing what the other pads on here. I'm trying to find VCC in. I can't remember what one it is on here. 92, 93, 92, 93. Okay. So I should have VCC at 82 volts on these drive ICs. And that should be pin number 3. Pin 3 looks like it's VCC, perhaps. Could you measure with respect to negative VCC? Yeah, but I can't do that with my scope because it's not floating. So I'm just gonna have to use it. I'm just gonna have to use reference here. So, this is obviously the VCC into the 2113, which is at negative 81 volts, which is about 12. It's about 93, 83. Yeah, it's about 12 volts lower than the it's 12 volts lower than the negative rail. Yeah, 12 volts lower than the negative rail we have on pin 3 VCC. And we should also have that up at pin number 1, 2, 3, 4, 5, 6, 7, 8, 9. We should have 81 up at pin 9 as well. And pin 10. So 9 and 10 should also be the 12 volt ref. Okay. On this other side, we don't have that. We have something different. On this other side, get this right, pin number 1, we have negative rail, which is correct. On pin 2, we have negative rail, which is correct. Pin 3, see over here, pin 3, we have 93 volts, not our 12 volts. We don't have our 12 volts. And so that must be something to do with the fact that we have 93 volts also on pin 3 of where this 7812 is meant to be. So there's something that's not right about that. So we need to find out why. And it could be a leaking or open capacitor. See, there's a couple of capacitors here. So you see there's a couple of capacitors here. So these might be between, they might have the negative rail on one side and the the regulated 12 volts on the other side. And if they are open, if they're shorted, then that might be the problem. Hi Bevis, I'm in Brazil. Awesome. Thank you for joining in the stream, buddy. So I'm just going to wait for the voltage to fall down a little bit to a safe level. I've got 5 volts there, and that's going to be fine. Turn the power supply off. And just going to remove the output board again, because it makes things a little bit easier to work on. I like the fact this comes apart. Very nice, very satisfying. So, okay, so let's see then. Why do we have our negative rail on pin 3? We shouldn't have anything on pin 3, because pin 3 is the output of the 7812. So that we shouldn't have anything on there. So there must be some reason that we do. So there's no short circuit between 2 and 3. Okay. Hi from Oklahoma, USA. How's it going, buddy? Thanks for joining the stream. We're looking at a Lanzar 7K at the moment. Lanzar OptiDrive 7K. Okay, I can't see any anything that's like straight away obviously shorted. There's no semiconductor parts that are like obviously shorted here that would cause there to be negative rail voltage on VCC. So perhaps the next thing that I'm going to do is I'm actually going to remove all of these 7812s just to see how the other ones react. So we know that the other ones here are fine and that the circuits that they're driving are not a problem. So I'm going to remove the rest of these three and compare what voltages there's meant to be on their legs when they're removed. Hi Katie, how's it going? Thanks for jumping on the stream. We're looking at a Lanzar 7K at the moment. Lanzar OptiDrive 7K. Appears to have a faulty voltage regulation circuit, 12 volt regulation circuit on the reference to negative rail. It had blown outputs and it had a blown driver IC. So a few things we need to look at here. Alright, so let's see. How do the other ones act now that we've taken those off the board? Do we have negative rail on pin 3? Is it just a reaction of it not being there? So let's see. Okay, 90 volts on there, so let's have a look. Pin number 3, 88. Okay, so no, it does actually. I've got 89. No, it's still too high. Okay, so our negative rail is floating between, what is our negative rail? Our negative rail is about 91. It's floating around a little bit between 90. It's floating between 89 and 92. Well, why is it fluctuating like that? It's like kind of pulsing a little bit. I think it's because my power supply is pulsing a little bit. So let me turn my power supply up just a tad. 11.2 volts. Okay, let's see if we got a stable. Okay, so 97 volts. Yeah, 97 volts is our negative rail. Yeah, dead on 97 volts. So pin 3 of the good one that was working fine before is sitting at 96. Okay, So it's like a volt. It's a volt lower. For whatever reason, 96.7. It's a volt lower. Pin 3 of the bad one, is sitting at higher. It's sitting at 98. Well, how is what? Okay, rare. There's definitely something funky going on with pin 3 on this side. So how and why is pin 3? No, it's back down at 97 now, so it's still slightly higher. It's still ever so slightly higher than the negative rail. Negative rail is 97.4 volts, right? Maybe not. Maybe not. It's kind of this is weird. It's leveling itself out now. Okay, but there's definitely something not right because it is higher than it should be. So pin 3 of the good one should be about a volt less. Okay. 97.8. And nothing. I wonder if I remove this driver board. Does that make any difference? I'm curious as to how this builds, so I'm going to apply the remote and watch carefully on the scope as to how this builds. Does it jump up? It jumps at the end there. So what does the good side do? Does the good side jump as well? Yeah, okay, they do both jump. Okay. Not sure then. Not too sure then what's going on there. Weird. Drabara says it's becoming a routine. Test the regulators without the IC in the board. Yeah, I was thinking of doing that. The problem is I don't particularly want to kill any more of these 7812s. So I don't have any more 7812s either. I've got one 78T12. I don't know what difference that is. I might need to look that up. So the only part that I've got left to drop in here is a KA78T12. So can anybody tell me whether the KA78T12 will work in the place of a 7812? Alright, let's put them back in and test with the ICs out the board. I'm going to just turn the amp on very, very slowly this time. So as to try not to kill whatever one I put in here. T is the same. The 78T12 is only 0.5 amp. Oh shit. No way. It's the same package. How is that? Okay, no worries. So I can't use the T ongoing then. I have to just use the T for some testing now. Hi Chevys, how's it going? Okay, so now the ICs are out the board. I'm going to just pulse the power supply very quickly, very small amounts, and see what happens to this regulator here. Seven, 8, T12, 3 amp, 12 volt positive regulator. Why did somebody else say it was 0.5 amp? Drabro. Why did you say it was 0.5? Either way, I'm gonna order some new ones for this anyway. Okay. So let's just pulse it very small amounts and see what's going on here. Okay, so we've got 9 volts on the rails, barely anything at all. So, we need to know the negative rail. So negative rail, let's give it negative 11 volts. We have negative 9, negative 8. So yeah, it's pretty much. So are these two being matched? Are these two matching each other? 6, 5, 4. Yeah, they're matching each other. They shouldn't. That's the problem. That's why it's killing it. That's what I thought. Okay. So look, if I just pulse the power supply again, very quickly for you to see. I'm going to get the rails, the negative rail, just down to like negative 10 volts or something. Negative 7. Okay. So the good one should be -5 and lowering, and then on pin 3 it should be like 1 volt, because on the bad one they're equal. Pin 3 and pin 2 are equal, so something is causing pin 3 and pin 2 to be equal, which is what is killing the 7812. So it's going to be some sort of leaking capacitor or diode or something. Cool. All right, so we have issues to look for then with this amplifier. I'm going to look at this on a different stream because I've got a couple of things to do. So yeah, with the Lanzar, we've got a couple of things to finish off on the Lanzar. I'm going to look at that on another stream. Michael says he reckons it's a diode. Yeah, there's no... So I've gone through the board and just looked for like obviously shorted diodes, and there's no obviously shorted diodes, but there could be a leaking diode. So what we'll have to do in order to find what the issue is with this one is we'll have to systematically start removing parts of the board until the voltage on pin 3 goes to where it should be. Actually, what we could do, here's a thought for you. If we struggle to find the component, okay, I have an inkling. If we remove all of the 7812s again from the board, okay, pin 3 is the output of the 7812. Now the fact that there's a voltage on pin 3 of the 7812 pad when it's removed, I think is just like a very, very low current thing that's kind of a bit of back feed from somewhere. And I think if we grounded pin 3 of the pad with the 7812 out of the board, I think it would stay at 0 volts and I think it wouldn't put any current. However, the pads that are bad, the 7812 area that's bad, there obviously is something that is passing some kind of considerable current to pad 3. So if I ground pad 3, then whatever is faulty, whatever is allowing the current to pass, will get hot on the board. So if I struggle to find the issue quickly by normal methods of removing and testing, then I might just ground pad 3, or I might ground it through a resistor, a current limiting resistor or something like that. And that should cause the faulty component on the board to heat up. Ugh. But until then, I actually feel like absolute crap, so I'm going to go and lie down and have a hot honey and lemon drink, because I feel absolutely dreadful just now. So thank you very much for everyone who joined in the slightly shorter stream this evening. Usually my streams are 8 hours, this is 2 hours and 20 minutes, which is not too bad. Yeah, I'm going to go and have a bit of a lie down, get an early night, I think. Why is it telling me to sign in? Look at this. How can I be live streaming if I'm not signed in? Strange. Anyway, yeah, like I say, once again, thank you very much for joining in the stream. What do we fix? Not much. Fix the crescendo possibly, but we need to check whether that fixed itself or not. So yeah, see you on the next stream, guys, and have a good evening.